Students, from your chapter Alternating Current, we were discussing the power consumed in the AC circuits. Okay, we have derived one equation for the power consumed or the power dissipated in the circuit, and we have just written that when the circuit will be completed, the average of sine square omega t's value is half, and that of sine 2 omega t's value is 0. Okay, so now we will see what the average power of the circuit is. So the average power, how to denote it? By P bar equals to half V naught I naught cos theta, which is equal to, how to represent this, students? We have seen in the class, it's V naught by root 2 into I naught by root 2. I have shown you this part. This I'm not going to repeat again. Okay. Cos theta. Alright. So from this step what we can write? Which is equal to, what is this? V naught by root 2, and I naught by root 2 is what? It's just VRMS dot IRMS cos theta, isn't it? Okay. So these are the this is the expression for the average power in the circuit. Okay. Okay. Now, uh, nearly no experiment can measure the instantaneous power, that is P. So every measurement leads to the average power P bar, that we have seen the expression of this average power, that is P bar. Now this P bar is referred to as the effective power and is usually denoted by the symbol P. Alright. So the effective power, or in other words you can say that is the true power of an AC circuit, is what? Value is, I am writing here, P equals to half V naught I naught cos theta, which is equal to VRMS IRMS cos theta. Alright. Okay. So students, we have seen that the power consumed in AC circuits is average value as well as its effective value. That means the effective power as well as the average power. Alright. Okay. Now students, we will learn about the power factor. Okay. This term must be new to you all. Okay. And this term is used in the case of these AC circuits. Till now, we have seen the power, the expression for the power in the AC circuits. Either the power is being consumed or dissipated. Now we will see that what is the power factor. Now students, in this particular equation, let's say this is the equation number 1. In this equation number 1, students, the factor cos theta, okay, this part, only this cos theta part in this equation number 1, okay. So this cos theta part in equation 1 is very important in the case of this AC circuits. This factor arises clearly due to the voltage current phase difference theta. Okay, this is happening for what? In the previously we have seen that theta is arising due to the phase difference between the voltage and the current. Okay, so here also we can see that this cos theta part is arising due to the voltage and the current phase difference theta, isn't it? So this cos theta part is called as the power factor of an AC circuit. Understood? Only this cos theta part. Please don't write that this full expression is your power factor. Only this cos theta. Understood? So if theta is not equal to 0, then the cos theta's value is less than 1, isn't it? Just recall your trigonometrical ratios chapter that you have learned in the maths. Okay, so the power factor in general reduces the power that is being consumed in an AC circuit, isn't it? Repeating once again. Suppose your theta's value is not equal to 0. I'm writing here. Theta's value is not equal to 0. Then obviously your cos theta will be less than 1, isn't it? So for this, the power factor, we can see that the power factor is reducing the power that is being consumed in an AC circuit to some extent. Okay, but for this, that means when your theta is lying between negative 90 degree to plus 90 degree, the power factor cos theta is never negative, isn't it? So as a result, the power at that time or at that interval that is consumed in the circuit can never be negative. Understood? We are talking about this part. This part is done. Okay. Now we are talking about this what? That when the theta's value will lie between negative 90 to positive 90, the power factor cos theta is never negative. So when the cos theta part is not being written negative, so the power consumed in the circuit can never also be negative, isn't it? Okay. As usually students, you know that the unit of power is watt, and to distinguish between P and the product VRMS, IRMS, let us talking about this. What is never used is the unit of VRMS and the IRMS. Okay, for this only. Okay, that is the usual unit of this product is volt dot ampere or V dot E. I am writing students here at the bottom. Volt dot ampere, or in short you can write it as V dot A. Okay, so incidentally, from the similarity with the DC expression, that is P equals to VI, P equals to VI, this is the expression for the DC circuit students, that is the P equals to VI DC circuit. I'm writing in short. Okay, this product VRMS and IRMS is often called as the apparent power of an AC circuit. Understood? This we are just comparing it. Okay, we are seeing the similarity. All right.